Today we're going to talk about reasoning using properties from algebra. Kind of a review of what you did last year in algebra. We're not going to learn this. We're going to learn how to justify the steps to solving an equation. So your algebraic properties are right here. These are all the properties that you've learned over all the years. And I'm not going to waste your time going over all of it. You've got this graphic on your notes. So go ahead and use that graphic and study this stuff. Okay, you need to know these properties. The first four properties here are not new. We've just put a name to them. This is how you solve equations. If you have to add the same thing to both sides, subtract the same thing to both sides, multiply both sides, divide. So we just put names to them. Now the reflexive property, the symmetric property, and the transitive property should all be new to you. And basically the reflexive property just says for any real numbers, they're equal to itself. Okay? And it seems like a simple property, but we'll be using it to prove statements in geometry. I know you're all excited about doing logical proofs. I know I'm so excited about teaching them. I love proofs. Okay, the symmetric property is if A equals B, then B equals A. A lot of you have been doing it instinctually. A lot of people don't like their equations to look like this. So what they do is they do this. And that is the symmetric property. Okay. The transitive property is like the law of syllogism that we just learned. Okay. And in fact, the law of syllogism is sometimes called transitive reasoning. So it's taking out the middle man. If A equals B and B equals C, then A equals C. So what we're doing is, since they're both equal to B, they have to be equal to each other. And then the substitution property you guys have been doing forever. We use that when we're going to substitute in. And when you're solving an equation, if you go from, say, x equals 4 plus 3 to x equals 7, what you're doing is you're substituting 7 in for this expression. All right, so let's solve this following equation, and we're going to justify each step. So in a formal proof, the first thing you do is you state your givens, or one of the first things you do. And in solving an equation, we state our given first. So we're going to say given. Okay, because this is just our equation. Now notice here what we've done, we've got negative 3x, so we've added 3x to both sides of the equation. So that's addition, property of equality. And you can abbreviate because this unit, you guys have learned, it's a lot of writing, very different, right? So now what we have is 9x plus 2, so we've combined those, equals 0 minus 16. So this actually technically has two things going on here. We're substituting, and we could say substitution actually for both. Substitution. Of course I can't. Substitution, right? And this negative 3x plus 3x giving us 0 is the additive inverse property, or inverse of addition. Okay, when we add inverses, it gives us 0. So there's really two properties on that line. So 0 minus 16, and the next step just becomes negative 16. Okay, and that has a property too. Okay, and that is the identity of addition. Now we are subtracting 2 from both sides, so that's subtraction. Again, I'm okay with abbreviations of equality. We're subtracting the same thing from both sides. Again, now 2 minus 2, I didn't really say plus 0 there. I probably should have. But we're doing substitution. Sometimes it's hard to think to break it down to the minor steps. Okay, we're substituting negative 18 in for negative 16 minus 2. And the next step, we're dividing both sides by 9. So that's division of equality. And then again, I've got 2 steps going on here. We could actually say 1x equals negative 2, and that would be division. So actually, we can just say substitution with that. Okay, and then if we wanted to, we could say x equals negative 2, which would be identity of multiplication. In geometry, we're going to mark these down to the smallest steps. And that's going to be our next thing we're going to look at, is we're going to do some simple proofs tomorrow. So I broke this one down even further. So we're going to solve 12 equals negative 3 times 4x minus 8. So we're going to distribute. So the first thing we have is our given. Then we're going to distribute the negative 3. Okay. We're now subtracting 24 from both sides. So this is subtraction of equality. Now some people might change that to plus a negative, and that would be addition. All in how you solve it. Okay, on this part, I've got substitution. Over here, I've got additive identity. Okay, 24 minus 24 is the same as 24 plus a negative 24. Got my x there, I see. Okay, and then again, 12x plus 0 is negative 12x. So that is identity of addition. We're dividing. So division of equality. Substitution. And then 1x is the same as 1 times x equals x. So that's identity of multiplication. Notice that we've switched this around. So this is our symmetric property. Okay, so that's just a little review from algebra. So these are our new properties. Reflexive, remember, means that for all real numbers, A equals A. Symmetric is if A equals B, then B equals A. And then transitive is knocking out our middleman. If A plus B equals C, and C equals 5, then A plus B equals 5. Or like our law of syllogisms. Remember, if P, then Q, if Q, then R, and then P, then R. Okay? Have a math-tastic day.